In this video, we're going to have a look at combinations and how they're different to a permutation. So a combination is a selection of objects where the order that we put these objects in or select them in does not matter. So we're going to go back to one of our very first examples using the word maths. So from those 5 letters, we're going to select 3 letters. So let's say we select the letters M, A and T. Now straight away in our minds, we're thinking, okay, well we've got 5 letters and we permutate 3, we get 5 times 4 times 3, which is 60. But we've got to remember that this is 60 arrangements. So not only have we selected these, we've actually put them in an order. So the problem with this answer is we've arranged them. We've got the same letters and put them in different orders. So let's have a look at what that would look like. Just with those letters M-A-T, we would have M-A-T, we could have M-T-A, we could have A-M-T, or A-T-M, or T-A-M, or T-M-A. So just with those 3 letters, we've got 6 different ways that we can arrange them. This number 60 is also considering choosing another 3 letters. What happens if we chose T, H and S, or T, S and H, and then arrange it as S, H and T, or S, T, H, or H, S, T, or H, T, S. So again, another 6 arrangements. With a combination, choosing the letters M-A-T is one selection. We don't want to have to worry about ordering them. So when we choose 5 letters from 3 letters from 5 letters, we only actually end up with 10 combinations because we're not worried about, as we see up here, the 6 ways that we can arrange each of those 3 selections of letters. So when we say I've got 5 objects and I'm going to select or choose 3 objects, there are only 10 ways in which we can do that. We can also think about this as our rule previously with permutations, n factorial over n minus r factorial. Let's take our original answer of 60 arrangements and remove the arrangement. So remember, when we're arranging 3 things, we've got 3 times 2 times 1, or 3 factorial. So we're going to divide by 3 factorial to remove that arrangement. So really we've got 60 divided by 6, and that's where we end up with just 10 ways of choosing 3 different letters. If we look at this using that permutation rule, we know that when we've got 5 objects and we're going to choose 3 from those objects, this here is the permutation part. And then what we're going to do is take away or reverse the arranging of those 3 letters. So what we end up having is 5 factorial over 2 factorial and by 3 factorial. So our 120 is divided by 12 and we get that 10. So when we're just choosing objects and not arranging them, we can slightly change our formula of a permutation by adding in this division of the R objects that we're choosing. So let's take a look at this in terms of some examples. In our second example, we are asked to choose 4 people from a group of 20. So using our rule, we could say we've got 20 people and we're going to choose 4, but we're going to remove the arranging, and that's removing the arrangement. So Otherwise, in our calculators, we could just say 20, choose 4. You can also write it in this format, and that will tell us 4,845. Have a go with that on your calculator to make sure that you can understand where your button is and that you get the same solution. You could also compare that of doing 20 permutate 4 and just see how much smaller your number is because you're only choosing those 4 and not arranging them. Example 3. There are 15 questions on a maths challenge sheet. Students must choose 9 of the questions to answer. How many possible selections of 9 questions are there? So we're not worried about the order they answer the questions in. We simply want them to choose from the 15 those 9 that they're going to answer. So we could say 15 objects, we're going to choose 9, but we're not going to arrange them. Or in our calculator, 15, choose 9. We get 5,005 different selections of 9 questions. In our last example, we've got 8 Year 10 students and 12 Year 11 students in a group. We want to select 7 students. So in total, I've got 20 students and I want to just choose 7. So 20 choose 7 is 77,520. So from these students, how many ways can 3 Year 10 and 4 Year 11 students be chosen? So now we're going to consider each group. So we're going to say from the 8 Year 10s, we're going to choose 3, and from the 12 Year 11 students, we're going to choose 4. Now, as you can see across the top, these add to our 20 students, and across the bottom, these add to the 7 we want to choose. And we can work these out on our calculator to be 27,720. In our last part, we've got how many selections only have Year 10 students. So from the 8 Year 10s, we want to choose 7 students, and from the 12 Year 11 students, we want to choose 0. And we get an answer of 8. The question is, what does 12 choose 0 equal? Perhaps you can come and answer that in our next class. In our last example here, it's a little bit different to a question. It's just using some algebraic manipulation. Using that rule, if we don't know what n is for the number of objects that we originally started with, can we solve for that? Well, using our formula, we've got n objects in where we have chosen 2, but we have not arranged them. And this should equal 91. Now, thinking about solving this, I'm going to multiply everything by 2 to get rid of this 2 factorial. So I've got n factorial over n take 2 factorial equals 182. Now, remembering that n factorial is just n times n take 1 times n take 2 times n take 3, etc. And n take 2 factorial starts from n take 2. So we can remove some of this, which leaves n times n take 1 as our numerator, equaling 182. And straight away I'm thinking, okay, I can see something to do with a quadratic here. I'm going to expand my bracket, so n squared take n. I'm going to bring my 182 over to make it take 182 and make it equal to 0. I'm going to factorise that quadratic, so n take 14, n plus 13, and so that n can be 14 or n can be negative 13. But thinking about the context, n can't be a negative number, n must be greater than 0, so n must only be equal to 14. I'd like you now to have a go at the following questions, and we'll debrief these in class in our next session.